Topic differentiation, and in this topic today we are going to see the implicit functions. What is meant by implicit functions, how to find the derivatives of the implicit function, and so on. Now we have expressed functions by so many ways. Most of the functions we deal with so far have been described by an equation of the form y is equal to f of x. Now, so many functions we saw by this way only. Sine of y is equal to f of x means y is equal to sine x, y is equal to cos x, y is equal to e raised to x, and so on. By this way, we have described the function. That means we have expressed the variable y only in terms of the variable x. So y is expressed in terms of x. Now it is not always possible to solve for one variable explicitly. Okay, what is the meaning of this? Every time we cannot write one variable in terms of the other variable, that is, or explicitly one variable we cannot write in terms of other variable explicitly. That is called those cases where it possible to solve one variable in terms of the another to obtain y is equal to f of x or x is equal to g of y are said to be explicit functions. So whenever, if it is possible, if you have given the function and if it is possible that we can express this y in terms of x or x in terms of y, then we say that the functions are explicit functions, and that form is called as a explicit form. Now, if an equation in x and y is given, but x is not explicitly function of y, that means we cannot express x as a function of y, and y is not an explicit function of x. That means if y is also not is not able to return in form of x, then either of the variables is an implicit function of the other. That means whenever it is not possible to separate the variable x in the given expression or the variable y, we cannot separate from the function. So x and y occur every time occurs together, then that type of functions are called implicit functions. So always keep whenever it is not possible to express x in terms of y or y in terms of x, then that functions are called as implicit functions. Now, how to find the derivatives of the implicit functions? Now differentiate both the sides of the equation with respect to x. Okay, x is the independent variable, and treating y as a differentiable function of x. Now collect the terms containing dy by dx on one side of the equation and solve for dy by dx. So now after differentiating the equation, whenever there are the terms dy by dx, so all the terms which contains dy by dx collect together, and all the terms with we don't have dy by dx to collect to other side. Then let us see some of the solved examples on these implicit functions. Now look for first example: x raised to 5 plus xy cube plus x square y plus y raised to 4 is equal to 4. Now is it possible? Is it possible to express x in terms of y or y in terms of x? It's not possible. म्हणजे काय, या दिलेल्या इक्वेशन मध्ये आपण x बाजूला काढू शकतो का किंवा y बाजूला काढू शकतो का? ते शक्य नाही. वी कॅन नॉट एक्सप्रेस दिस फंक्शन wholly x in terms of y or y in terms of x, so that is called implicit function. Now how to differentiate the implicit function? Take the derivative on both the sides, differentiate with respect to x. So each term will be differentiated by with respect to x. Now here derivative of x raised to 5 is 5x raised to 4. Then derivative of x y cube, x is as it is, derivative of y cube plus y cube as it is, derivative of x. As there is a product of two functions, we have to use product rule. Similarly here is also there is a product of two functions, so we have to use the product rule. Derivative of y raised to 4 with respect to x is 4y raised to 3 dy by dx, and 4 is a constant, its derivative is 0. Now there are three terms which contains dy by dx, so we will group them together and other terms will group other side. So taking dy by dx common from these two terms, and then this factor will be uh, divided to the other side. So this is the derivative of the function, implicit function. Now the second, y cube is y cube plus cos of xy is equal to x square minus sin of x plus y. Here is also not possible to write y in terms of x or x in terms of y. So we have to differentiate this both the sides with respect to x. Derivative of y cube is first of all, you see, derivative of the first term plus derivative of the second term is equal to derivative of the first term minus derivative of the second term. Now y cube, its derivative is 3y square dy by dx. Cos of xy, cos derivative of cos of f of x. Here you have to use the formula. Derivative of cos of f of x is minus f of x into f dash of x. Similarly, here is also sin of f of x. Its derivative is cos f of x into f dash of x. Okay. So after using that formula, d by dx of xy, now here there is a product of two functions. So how to find the derivative? To find the derivative, keep first function as it is, derivative of the second function plus second function as it is, derivative of the first function. After simplifying it, you get 3y square dy by dx minus x sin xy dy by dx minus y sin xy is equal to 2x minus cos of x plus y minus cos x plus y dy by dx. Okay, so after simplifying it, you will able to write this expression as, after taking dy by dx common and the other this term will go to other side, dy by dx is 2x plus y sin xy minus cos x plus y upon 3y square minus x sin xy plus cos of x plus y. Now the next example is dy by dx, find dy by dx if x square plus e raised to xy is equal to y square plus log of x plus y. Here we cannot separate x and y in this equation, so we have to use the derivatives by using implicit functions. So differentiate this function with respect to x. Here uh, derivative of the composite function, that rule is expressed. So d by dx of x square plus d by dx of e raised to xy is equal to d by dx of y square plus d by dx of log of x plus y. Derivative of x square is 2x. Now derivative of e raised to x y is e raised to f of x. Its derivative is e raised to f of x into f dash of x. And y square, its derivative is 2 times y dy by dx. Log of f of x, its derivative is 1 upon x plus y into d by dx of x plus y. So again we simplify it. Derivative of, to find the derivative of xy, we have to use the product rule. First function as it is, derivative of the second function plus second function as it is, derivative of the first function. So 2 times y dy by dx plus 1 upon x plus y d by dx of x plus y. So after simplifying it, take the terms which contains dy by dx to the one side and take dy by dx common from all the sides, all these terms. Then we get dy by after taking LCM, 2x into x plus y plus y e raised to xy into x plus y minus 1 upon x plus y. Similarly, take the LCM into this side also. So both the sides will have the denominator x plus y. So cancel each other, and then we get dy by dx as 2x in bracket x plus y plus y e raised to xy times x plus y minus 1 upon 2y x plus y minus x e raised to xy times x plus y plus 1. This is the derivative of the function. Now look at this function. This is the standard example. You can take any value of m and n. You can take any value of m and n, but its derivative is always y by x. This is a generalized formula. If they may give x cube y square is equal to x plus y raised to 3 plus 2 is 5, then also its derivative is y by x. So given expression is, we cannot separate x from this, or we cannot eliminate y also. So differentiate both the sides with respect to x, we get log taking initially we will take the logs on both the sides. Okay, after taking the logs on both the sides, log of the product is sum of the logs, and okay, log of the index property we will use here. So m plus n times log of x plus y. This is by this method we get the answer in minimum steps. If directly differentiate, then also there is no problem, but we have to use the product rule in that case. So taking the derivatives of each term, and then we will take this dy by dx to one side, take dy by dx common from the two sides, and simplify the remaining terms. After simplifying, you can see that both the sides denominator contains x plus y, and also both the numerators on the both the sides are same, so they will also cancel each other, and what we get, dy by dx is equal to y upon x. Any expression which is of this form, we will always go through by this way. Okay, to find the derivative of the given function. Sine of px raised to m minus q y raised to m upon px raised to m plus q y raised to m is equal to r. Then you have to show that dy by dx is equal to y by x. Use the same method. Sine of something is equal to r is given, so this factor or this quotient is equal to sine inverse of r, where r is a constant. Okay, so the sine inverse of r is t for some t where t is also constant. Now, so multiply this denominator to take this denominator to the right hand side, and simplify it. What you get, px raised to m minus ptx raised to m is equal to qy raised to m plus qty raised to m. Then simplify, group the terms of x raised to m and y raised to m together. Then we find the value y raised to m is equal to this expression, and then this p is also constant, t is also constant. So whatever the expression we got here, we called it as some another constant, say s. Okay, then the equation is of the form y raised to m is equal to x raised to m, and we can differentiate this equation with respect to x. So after differentiating the equation, we come to this step, dy by dx is equal to s times x raised to m minus 1 upon y raised to m minus 1. But in then what is the value of s? What is y raised? What is the value of s? S is from this step. S is y raised to m upon x raised to m. So we will put that here. So what do you get? This is y raised to m minus 1. This is x raised to m minus 1, and this is y. So the here 1 y by x is more. So after cancelling the terms, and we will get y upon x. So the derivative is y by x. It is so simple because we have taken, after simplifying the derivative, we have taken the derivative, so it is possible to write the function. Now this is also same. We have to find the derivative, and we have to show the derivative as x square tan square y upon y square. Now second inverse of this is given, where a is a constant. Here we will not eliminate a. Why we are not? If I would have taken this second inverse to that side, I will get to sec 2a. And after differentiating, as a is constant, sec 2a is constant, so it will get eliminated, and whatever the expression will remain, that is in terms of x and y only. But we don't want to eliminate the a from this expression, so here we will not eliminate a, as answer contains. So after taking the reciprocal, we get cos inverse of x cube minus y cube upon x cube plus y cube is equal to 2a. So cos, we will just take this cos to that side and then multiply this x cube plus y cube to cos 2a. Then simplify it, then we will group the terms of x cube together and y cube together. From that we will calculate our y cube. It is 1 minus cos 2a upon 1 plus cos 2a, but 1 minus cos 2a is 2 sin square a and 1 plus cos 2a is 2 cos square a. 2 will cancel and we get tan square a. So after differentiating it, we get derivative of y cube is 3y square dy by dx, and tan square is constant, so we have to find the derivative of x cube only. It is 3x square. So both the sides have 3, so we'll cancel each other, and then we get dy by dx as x square tan square a upon y square. This is the derivative of the function. Now the next example is this. You can see that the infinite terms are there. From infinitely many terms, if we take one term out, then there is doesn't make any difference in that expression, and again we have the same infinitely many terms, so that I can put y for that infinitely many terms. So we will simplify the terms and we get y square is equal to tan x plus y. Then we will differentiate it with respect to x, and then taking dy by dx common, and we will write the answer dy by dx as sec square x upon 2y minus 1 as usual. Similarly, in this the next example, here is also it is not possible to separate x and y from this. So we put x is equal to sine alpha and y is equal to sine beta. So we can get our sine inverse of x is alpha and sine inverse of y is beta. So equation 1 becomes this. Then cos alpha plus cos beta is equal to this equation. So after simplifying, adding 2 cos alpha plus beta upon 2 cos alpha minus beta upon 2 is equal to 2 twice a cos alpha plus beta upon 2 into sin alpha minus beta upon 2. Therefore cos of alpha minus beta upon 2 is equal to a times sin alpha minus beta upon 2. Simplify, cot alpha minus beta upon 2 is equal to a. So alpha minus beta upon 2 is cot inverse of a. From this we get alpha minus beta is equal to 2 times cot inverse of a. But what is alpha? Alpha is sin inverse of x. What is beta? Beta is sin inverse of y. So after simplifying, differentiate with respect to x, find the derivatives and separate it by dy by dx. So this is the solved examples on the implicit functions.